So today we're going to talk about 12.1 tree diagrams, and factorials. Two things that really don't have a whole lot to do with each other, but we're going to put them together in one section. So let's talk about tree diagrams first. Tree diagram is a probability tree. It's a visual aid that shows all possible outcomes. So that's really what it is. It's just a visual aid. It helps you visualize something that could have many possibilities. So for example, we'll do some pretty simple ones to kind of get the point across. First example says a bag has 2 red marbles and 3 white marbles. Show a diagram that represents you picking a marble, replacing it, then picking another. So the way we do a tree diagram is pretty easy. I always like to put a little dot right here, kind of indicating this is where we're at and where we're going to start. And then you're going to just start branching off with your possibilities. So for instance, if I'm sitting here, I have a choice. I have a bag, I reach my hand in there, and 2 possibilities could come out. I could either pick a red marble or a white marble. So I'll have 2 branches. Okay, this is if I picked a red, and this is I picked a white. And so what I like to do then is along these lines here, I like to put the probability of that happening. So there's 5 marbles total, so the probability of me picking a red would be 2 out of 5. And the probability of me picking a white is 3 out of 5. Now the next part is that it says we are going to replace it. So that means we're going to take the marble, whichever one we picked, throw it back in. And so we're going to pick another one. So let's just say we went down this branch, we picked a red, threw it back in, and now we're going to pick again. So what are my choices? Well, my choices are I could pick a red or I could pick a white. And what's the probability of me picking a red this time? Now since I put the original marble back in, again it's 2 out of 5, and this is 3 out of 5. Okay, so let's come down here. Well, what if I picked a white to begin with? Well, I pick a white to begin with, throw it back in. What are my choices? Again, I have the choice of red, and I have the choice of white. And once again, because I threw the marble back, this would be 2/5 and this would be 3/5. So, and that's it. So that's what it's asking is pick a marble, throw it back, pick another. So this is representing that possibility, or those possibilities, pardon me. So we're not quite done yet though. Let's talk about the probabilities then. Well, first of all, the way you write probabilities, or a common way to write it, is this: P, and then what's the probability of me going through and doing that and picking 2 reds? So kind of following this branch, red then red. So I'd write P and then R and R. So that means probability of picking a red and then a red. Well, to figure that out is pretty easy. You simply just take the numbers that are along that branch. Probability of picking a red the first time, probability of picking a red the second time. So the probability is 4 out of 25. So that tells you if you were to do this 25 times, this picking 2, replacing the first one, you would get red and red 4 times. And so let's do that for all these. What's the probability of this one? So picking red, then white. Probability of picking red and then white. So that would be 2/5 times 3/5, which would be 6/25. And what about this one? Picking a white and then a red. Well, hopefully this will make sense that it's the same as the one we just did. And what's the probability of picking a white and a white? That's 3/5 times 3/5. Okay, so those are our probabilities. Now, I could ask a lot of questions out of this. For instance, I could ask you, what's the probability of picking, well, I could ask these, but I could also ask, what's the probability of picking just a red marble? Well, the probability of picking 2 whites is 9/25. So what do you think the probability of picking just any red marble? Doesn't matter if it's the first one, doesn't matter if there's 2, doesn't matter if it's the second one. Well, obviously that, if we take a look at our numbers, you have this one, and this one, so that would be 16/25. Now another thing for you to check is this, that if we take a look at all these numbers, 4 25ths, 6 25ths, 6 25ths, 9 25ths. Okay, these probabilities should add up to 1. And hopefully that makes sense. I mean, if we're going through this scenario, and these are all my probabilities of these different situations should occur, well, to add up all those possibilities, it should be a whole. It should be, there's a 100% chance of us doing something, and so that should be true every time. That when you add these up, they should add up, oops, sorry, I'm off the screen a little bit. These should add up to 1 every single time. So, something to kind of check. Okay, so let's move on. Let's go to another one. Give you a chance to try and do this one. So this would be a great time to just hit pause and read it and try and do the tree diagram on your own. Okay, so let's see. It says there are 2 jars, one white and one brown. The white jar has 3 green balls and 1 red. The brown has just 1 red ball in it. Draw the tree diagram representing you picking a ball from one of these jars. Alright, so here I am, starting right here. Now you have a couple choices here. Even though you're just going to pick one ball, you have a couple choices. And the first choice is, are you going to pick out of the white jar or the brown jar? And what's the probability of that? Well, it's 1/2, because there's only 2. So you have a choice. Now if I pick out of the white, now there's, in the white it says there are 3 green balls and 1 red. So I could then pick a green, or I could pick a red. What's the green? 3/4. Red, 1/4. So what's the probability then of picking out of the white jar and then a green? Well, it's 1/2 times 3/4, which would be 3/8. What would be the probability of picking out of the white jar and then getting a red? Well, 1/2, then 1/4, so 1/8. Okay, now let's come down here. Now if I pick a brown, if I pick out of the brown jar, we only have one choice. It says it just has a red in it. So what's the probability then? Well, it's just 1. It's 100%. You're going to do it no matter what. So what's the probability of picking a brown and then a red? Well, that's easy. It's 1/2 times 1, or 1/2. And again, if you notice, 3/8 plus 1/8 plus 1/2 adds up to 1 again. So let's answer a couple of these questions that I have down here. It says, what's the probability that the jar is white and the ball is green? Well, by doing this, that's pretty easy to figure out. Probability the jar is white, ball is green. There you go, 3/8. Now, what about this one? What's the probability that the ball is red? Well, we have a situation here where the ball is red and the ball is red here. So this is 1/8 and this is 1/2. So the way we figure that out is we simply add those fractions. If you add those fractions, we end up getting 5/8. And that's basically all there is to it. Now we can get a lot more complicated than what we did right there, but for the most part, that's what we need to do. So hopefully that makes sense to you. We'll do some more in class. I would like to move on, though. I'd like to move on to factorials. Now, a factorial, this will be fairly short and to the point, but a factorial is simply all numbers or all integers have factorials. And let me actually start with the way it's represented. If I have some number and then we have this exclamation point, and what that exclamation point means is this. You're going to take that number, times it by the integer, one integer less than it, times integer 2 less than it, integer 3 less than it, etc. So if I ask you what the factorial of a number is, like the factorial of the number 4, what I'm asking you to do is simply multiply 4 times the integer below, and there. So we're going to multiply. If I say 4 factorial, you're going to do 4 times 3 times 2 times 1, which is very simply 24. That's it. Now, again, just like anything else, we can get a little more complicated. If we call that example 1, we can do example 2. And if I were to say 8 factorial times 3 factorial over 10 factorial, what would that equal? Well, you could very simply, 8 factorial is just 8 times 7 times 6, 5, 4, 3, 2, 1. And then 3 factorial is 3 times 2 times 1. Move that over. Then 10 factorial is just 10 all the way down to 1. And if you look at it, you can just do a bunch of canceling. So like the 8's here cancel, 7's cancel, 6's cancel, 5's, 4's, 3's, 2's, 1's. And so as I look at it, I see up on top I just have 3 times 2 times 1, which is 6. And on the bottom I have 10 times 9, which is 90. Okay, which obviously you can reduce that a little bit. You can 3 will go into both. 2 over 30. Now the other nice thing is that a lot of your calculators will have a factorial button also. They'll have an exclamation point. Now we'll have to talk about that in class because all of our calculators do it a little bit differently. But that is the nice thing. They do have factorial buttons. So that's all I really want to talk about with factorial. I just want to give you the basics, so that way in class we can go a little bit more in depth. Hopefully this makes sense. This is a pretty simple idea, but it's important for us when we get into permutations and combinations, which is coming up next week. So as always, if you have any questions, make sure you ask or write them down and ask them when we see each other in class. All right, thank you.